So this problem says solve the inequality algebraically. Even when this quadratic is written and I'm told to solve it algebraically, I will do some algebra for it, but I'm still going to do a visual model to find my solution. And math is connected between algebra. We've got our equation process or visual process, and we verbal explain it. We want to go ahead and do a drawing. But to do the drawing, I want to factor this to know where would this touch the x-axis. The question is asking, when is this bigger than 0? Well, I want to know when is it equal to 0. So off to the side, I'm going to say x squared minus x minus 72. I want to know when it's actually equal to 0, because then I can decide when it was above or below 0. So to do this problem, I want to factor. And to factor it, most often students run to the magic x, and as long as they do the magic x properly, we'll be in great shape. So we put a negative 72 on top, because negative 72 times the 1 gives me the negative 72. And then a minus 1 in the middle for my b value goes in the bottom. And then I just got to figure out what multiplies to be negative 72 that adds to be 1. Negative 1, I apologize. And that should be negative 9 and 8, which means my factors are going to be x minus 9 and x plus 8, which means that this touches the x-axis at x. Well, let me write the x minus 9 equals 0 part and the x plus 8 equals 0 part to have the zero product property show up. And then I add the 9, so I get x equals 9. Subtract the 8, so I get x equals negative 8. Now is where I get the visual of this problem. So what's happening is on the x-axis, I have the leftmost spot is negative 8. The rightmost spot is positive 9. And what's going to happen is my parabola is a happy parabola. I know that because the a value is positive, which means I get a happy parabola. All I do is draw a happy parabola in here. That happy parabola answers the question. When is this expression bigger than 0? Well, it's bigger than 0 when I have arms above the x-axis. I have this region left of negative 8 is all positive, and this region right of 9 is all positive. So I just have to come down here in my answer box and describe when that happens. So I get everything left of negative 8. The way that we describe that is we want parenthesis negative infinity to 8, negative 8. Now we don't include, this means we use parentheses when we don't have an equal sign. If it was greater than or equal to, then I would use a bracket symbol. But here I don't. I use my parentheses. So parenthesis negative 8. And then I use a union symbol, and then I start picking up at 9 again, and then run off to infinity with more answers where the quadratic is positive. Now that's just one way to write it. I could also write it in interval notation where I say this whole phrase is x less than negative 8 or x is greater than 9. Either answer will suffice, whichever way you are more comfortable writing the answer set. So now we're going to take a look at what it would do if I had graphed this on Desmos to get you a visual of how this actually looks if you had just graphed the inequality. So graphing the quadratic, this is the one that I drew. It's actually the right height with the right y-intercept to negative 72, so I can't see it as off the screen. But if I just copy and paste this into the next line below, and then go ahead and write the inequality greater than 0, what Desmos does for me is it shades everything left of negative 8, and then it puts a dotted line to not include negative 8, and then it picks up shading again at 9, and then it shades off to infinity to the right, all the solutions that are larger than 9. So this is the visual model of what we algebraically did over here on the left. And again, by algebraically, I actually still graphed. So I'm going to use a graphical model to represent and answer these types of problems. Now, conveniently, factoring guides me to those points where Desmos just plots it, and I can see it right away. and steal these two solutions without having to go through the work of factoring. So let's take a look at another example. This time, when we factor, we want to notice that this one is less than or equal to. And so as I factor, I'm going to get a graph that's also a happy face parabola. The two values that I find for x are going to bound the region where this is going to be shaded between, because this says less than or equal to 0. So I'm going to be bounding with brackets a region in the middle of two x-intercepts. So we want to go ahead and factor using the magic x with 40 on top and 14 in the middle, which conveniently looks like 10 and 4 to me. And so I'm going to factor and get x plus 10, x plus 4. You go ahead and set that equal to 0 so that you can figure out what those zeros are. So I get x plus 10 equals 0, x plus 4 equals 0. Subtract 10 from both sides and get x equals negative 10. Subtract 4 from both sides and get x equals negative 4. Now what that tells me is this leftmost bound is negative 10. The rightmost bound is negative 4. And so my shading, because it says less than or equal to 0, that's this region right here where the graph goes below the x-axis. So right here is the region of the graph that would be below, because I had a positive a value at the beginning of the function. So then I have to analyze and decide that my solution set is the region between negative 10 and 4. So there's two ways to write that. I can write it with a simple inequality and just say negative 10, comma, negative 4. Now, I put a parenthesis there. It needs to be bracketed. Bracket on both because it does include here. So there's one way to do it. Or you have to write with the and conjunction. You don't actually write the word and, but you write negative 10 is less than or equal to x is less than or equal to negative 4 if you're going to write it as an inequality statement. This and conjunction means that x is between those two, from negative 10 to 4. So that's what you do if it's between.